Welcome to 7.2 Properties of Exponents. This is kind of a review lesson because you've already used a lot of this in Algebra 2 or you've seen it in Algebra 1 with these exponent properties. A couple things are new. But the first one is the product of a power. This is when you multiply two of the same base, then it becomes x to the m plus n power. Just to kind of give you an example that might be a little bit more clear. If we take x squared times x to the third, we get x to the fifth because we add the 2 and the 3. 2 plus 3 would give us 5. So that's what we would get for our answer. When it comes to quotient of a power, that's where we do the opposite or the inverse operation, which would be subtraction when you're dividing. So this is x to the m minus n. We saw this a lot in the last unit when we were working with like the division factors. So a more concrete example of this would be if I had x to the fifth divided by x squared, I would get x to the third because 5 minus 2 would give us 3. Power to a power ends up being a multiply situation. So it's m times n. So if I do x to the, let's say 4, and then x to the fourth squared, that's the same as x to the fourth times x to the fourth, or in this case, x to the eighth, because you would take 4 times 2, that would give you 8. I don't need to box that. But you just multiply those when it's power to a power. Zero exponent, this is the best one of all. Anything to the 0 power equals 1. Just to kind of explain that here in shorthand way, you can think of that as x squared, or let me do it with numbers so it makes more sense. 2 squared, 2 to the first, 2 to the 0. This is equal to 2, this is equal to 4, and then 2 to the third is equal to 8. So if I go like forwards, I know that I'm multiplying by a factor of 2 each time. So I would go times 2 to get up here, times 2 to get up here. But if I'm going backwards, then it's the reverse order. If I'm going inverted, it would be divide by 2, divide by 2, and then divide by 2. When you divide 2 by 2, you do get 1. Or you could think of it like this. If I had 2 squared over 2 squared, using the previous rule from about subtraction, you would end up with a number divided by itself, which is always 1 or 2 to the 0, if we were to think of it like through subtraction. But you do get 1 regardless. Negative exponents, we saw this in the last lesson. What you do is you just bring the entire base term to the bottom of a fraction, so it becomes 1 over x to the m power. Now I shouldn't say just the bottom, because you can have negative exponents on the bottom of a fraction, then they would go to the numerator. But in this case, it would just look like this. And then power to a product or quotient. This is just to remind you that if you're taking something to an exponent, it affects both terms or all terms inside of the parentheses. So this is the same as x to the m, y to the m. It doesn't just affect one of them, it affects both parts of it. Same thing if you have a fraction. We would distribute that m to both exponents in that fraction. So this would become x to the n times m over y to the m. So it affects all the parts within the parentheses. All right, now we're just going to do some simplifying here. X squared times x to the fifth. We saw this earlier. You've seen it a lot of times. You just add the exponents. We get x to the seventh. Similarly here, we'd have 3 squared times 3 to the fifth, which is 3 to the seventh. We could type that in our calculator or do it by hand, but in this case, we're just trying to practice with the exponent rules, so 3 to the seventh is fine. Here we do have the same base, but now we have those fractional exponents. So whenever we're multiplying with the same base, we have to add those. So this is 1/2 plus 2/3. So we have to remember what to do when we're adding fractions. Good thing we just practiced this, but we need a common denominator. So I'm going to multiply this one by, not 3, 2 over 2. I'm going to multiply this one by 3 over 3. Then I end up with 4 to the 3/6 plus 4/6, because remember you just multiply across. And then that's going to simplify to 4 to the 7/6 power. That's the answer that I'm going to be looking for here. All right, simplify each expression using properties of exponents. So now we're doing power to a power. So this is where you got to be careful. We're not adding anymore, we're multiplying. 2 times 5 is 10. So this would be our answer. This one here would be 3 to the negative 10 power. You should never leave your final answer with a negative exponent though. You should rewrite it so that it becomes positive. So then we would rewrite this as 1 over 3 to the 10th. Not negative. Our answer does not change to a negative just because you have a negative exponent. That's a very common mistake. It just goes to the denominator in this instance. And then here we have two fractional exponents. So we need to make sure to multiply those. So it's 3/4 times 4/7. These 4s will reduce, and our final answer would be 25 to the 3/7 power. If you forgot to reduce that at the beginning, you could simplify it at the end. But 3/7 is the simplified version. Okay, now it's just a little bit more mixed practice with some of these. X to the 2/3 times y to the 1/3. In this case, we could rewrite this in like a radical form, but since we have different bases, we're not allowed to add them. So this is already simplified if we wanted to write it in terms of exponents, or if you wanted to write it as a single radical, since they share the denominator of 3, you could write this as the cubed root of x y squared, because it's, I wrote that in the wrong order, x squared y, because the x has the squared, y is by itself. So this is one option that you could write that as. This one here, again, it's really tricky because it's 3 to the 1/2, 6 to the 1/2. If the bases are different, because this one's 3 and this one's 6, you can't just add the exponents or multiply them. They have to have the same base in order to use the exponent rules. But what I could do is rewrite this as the square root of 3 times 6, which would end up being the square root of 18. So I guess it was a little mistaken here, but 3 times 6 is 18. So it does work here since they have the same exponent. We could write it as a radical. But it's just one of those things you have to be really careful with. So we could write this as 18 to the 1/2 power. Here, 16 over 25 to the 1/2 power. That's the same as the square root of 16 over 25. Now I took the whole fraction as a square root. And thankfully for us, 16 and 25 are perfect squares. This is another property you're going to want to remember. But you can rewrite radicals on the top and the bottom. If you're taking the square root of a fraction, you can take the square root of the numerator and the denominator individually. And the square root of 16 is 4, the square root of 25 is 5, so this is the answer we're looking for here. This one we are multiplying. Note we have the same index. You have to have the same index in order to multiply. Similarly to how the problem up above, we needed to have the same exponent. So here we needed the same index in order to do that. So now we can just multiply the common or the like terms together. So our answer is going to be the cubed root. That part stays the same. 2 times 6 is 12. And then we would do x squared, x to the 5th. Since we're multiplying, we can get x to the 7th. So this would be our answer here. Okay, a few more to go. This one here, when you're simplifying, this is the same as 3 over the square root of 3. I like to rewrite the fractional exponents as radicals because it just kind of, we're used to radicals. So now we would recognize the fact that, oh, we're not allowed to have a square root on the bottom. So we would multiply by the square root of 3 over the square root of 3. This would give us 3 square roots of 3 over 3 because the radicals would get rid of each other, or you could think of it as the square root of 9 on the bottom. So this would be the simplified answer that we're looking for. And then here, this one's tricky because we have x to the 5th over 4y to the 4th. I'm going to separate this into each of their own square roots. So on the top, I know that I could break this into groups of x cubed, x squared, and then I could do x and x squared. So here's a group that I could pull out. So then my answer would be x squared, and I would still have this lone x left inside, over, now the bottom, 4 is a perfect square, so that would come as 2. And then this could break up into a group of perfect squares as well, so we can pull out a y squared. So then this is the answer I'm looking for on this one. Okay, last little part here. We have the cubed root of a square root. Now this looks intimidating. If you were to take this out of context or try this without any insight, you might feel a little overwhelmed. But let's just take it slow for a second. Let's rewrite these in the fraction form with those fractional exponents. So I'm going to write this as 64 x to the 8th. And then this is a 2, so we can assume that that's to the 1/2 power. That's the same as the square root. And then I'm just going to add one more layer of parentheses. And then since I'm taking this to the cubed root, that's the same as the 1/3 power. So now let's just work our way down. I know that these are going to multiply. So I'm going to get 64 x to the 8th. And that's going to be to the 1/6 power. Now what I could do here is I could rewrite this as a 6th root. I know we haven't done a 6th root, but it's the same idea as everything else we've done. We're just looking for groups of 6. So 64 can break into, let's do 8 and 8, 4 and 2, 2, 2, 4 and 2, 2 and 2. So 64 is actually a perfect 6th power because I can take out a whole group of 2's. So I would get 2. And then the other thing I note is it's x to the 8th. If I were to take 8 and split it into groups of 6, I could get one whole group and I'd have 2 left over. So then inside of the square root, I would still have x squared. So this would be our answer. Now I'm going to show you guys kind of a cheat code to this. If we look back at our index here, we have 3 and 2. So that 3 times 2 is 6. So we actually could have skipped straight to this part. I could have rewritten this as the 6th root of that right away if I just noted that I could multiply those two. So kind of a little cheat code for that. This problem wants us to think backwards. It says what 4th root simplifies into 3x cubed y times the 4th root of x squared y. So if I were to approach this problem, it wants to know, like, this is the simplified answer. This is what I'd be looking for normally. We're trying to work backwards. So since it's a 4th root, we want to do the opposite because this part here, this is what came out of the 4th root. So to undo that, we are going to take all of these to the 4th power. And then we're going to multiply that with what's ever left inside, which is this x squared y. So if you recall, we have to make sure to take the 4th power, and it's going to affect every term here. So it's going to be 3 to the 4th power. Power to a power is multiplying, so x to the 12th, and then y to the 4th. Then I'm going to multiply that with x squared times y. 3 to the 4th is 3 times itself 3 times. That's just going to be 81. Then we're going to combine our x to the 12th times x squared, which would give us x to the 14th, because you'd add the exponents. And then we would have y to the 4th times y, which would be y to the 5th power. So this is our answer here. That's what would reduce into this fraction, or excuse me, this radical. If you're struggling with that idea, you can go ahead and take the 4th root of this whole thing, and you should get the same answer as what we started with here, if you wanted to double check that. Okay, and then just a quick little review between these. Remember that x plus 4 squared is the same as x plus 4 times x plus 4. It's taking the entire parentheses times itself, whereas this is 4x times 4x. Here we would have to do the FOIL process, so we'd get x squared plus 4x plus 4x plus 16, and resulting in x squared plus 8x plus 16. Whereas these would end up being 16x squared. We get two completely different answers. So make sure you're cautious when it comes to the squaring between parentheses like that. And that is it for